some dance moves look a little bit better when other people do it. We have talked about how to discuss those numerical interactions because once you see the picture, that's going to be the only thing you want. So let's take a look at how we might graph it, keeping in mind the wording that we want to use. And so to start with, let's explain the effect of age. If I want to explain the effect of age, then I have to have a value for hours. And I guess we'll call it hours hat, so that we can tell that these are values for the prediction, not necessarily the values that were in the data set. Let's give it a value that's somewhere between 0 and 50, since that's the range. So I'm going to start with 0. That's a low value, right? Next, I'll pick something middle and high. How many should you pick? Well, we'll talk about that in a second. Now, age is what I'm trying to explain. So for age, I'm not just going to give it a value. I'm going to give it a whole sequence. A sequence that ranges from, it looks like 20 is a low value of age and 80. So based on that histogram, age goes 20 to 80. So 20 to 80. And length just says how many lines do I want to put in there. I'm going to give it a decent amount, let's say 1,000, which is easy for computers to do now. 20 years ago would have been unthinkable. Now, brain is what we're trying to predict. So what is the prediction equation for brain? Well, if I run a summary command, here's that output. That's the same output we spent all last video looking at. And so all I'm going to do is put this equation in as my brain hat, meaning the predicted values for the brain function. 96.73, because that's the intercept, minus 0.0666358. 3 times, that's times age, and I did have the negative there. And we want to use our predicted values, so age hat, plus 0.18389 times hours, and I'm going to call it hours hat, minus 0.024605 times. Now what's really funny is I ran all this code with more of the video and I finally found my error. I called this brain hat, but brain hat's what I'm trying to predict, and I needed hours hat here. So this is a great example of something that takes 10 minutes to debug, and so I actually backed the video up to where I first did that, so you don't have to watch me say, why isn't this working? Let's run hours hat, age hat, and finally that's running without an error. I'm going to break this into 2 lines so that you can see it in the video. Okay, what's next? I'm trying to predict age. So here's where I graphed age by brain, and I want to draw a line for when hours equals 0. So I'm going to have the lines of my predicted brain values based on the predicted age values, which come from an equation using an hours of 0. I'm going to color it red because I like red, and I'm making the line width thick at 3 so that you can see it on the video. Boom! There it is. Well, that's not the end of the story. That was only what happened when hours was set at 0. So let's try doing it again, but this time I'm going to have hours set at 25. So I'm going to rerun that part. Now here's where we originally plotted the data, and I don't want to run it again, or else it'll redraw the plot over, which would erase my red line. So now if I make a new line, let's color it blue, let's spell blue, and look, there's the shift as we go to 25 hours of work. And it wouldn't be hard to put hours up at the max amount. I'm going to copy what I had before, and what do I need to change? I need to change hours from 25 to 50, and I might as well delete this because I don't want it. And now if I rerun it, let's not do blue, let's do yellow. Won't show up very well. How about green? And there we have our 3 lines. Here's what happens when hours are low, and when hours increase, and when hours are super high. We're really going to need a legend so that people can tell what's going on. Bottom left, we have hours starting at 0, 25, and then 50. The colors are red, blue, green. Here's where I made my line thick so that you could see it on the video. And I wanted to draw lines, not dots. And what's the chances work without any errors? Yay! I feel kind of happy about that. Now, can I explain this to a client? Sure. As you get older, brain function drops. People who don't work, their brain function only drops a little bit. People who are working a bit, their brain function drops pretty dramatically. People who are working lots as they get older, their brain function plummets. Oh, wow, this would be interesting. Can you imagine how much people would want to write an article about this? But to be fair, we've only really explained the effect of age. This doesn't count as trying to explain the effect of hours. We need to do the same thing from the hours perspective. Now, I was about to do this all while pausing the video, but it occurs to me it might actually be helpful to show you that you copy and paste to help emphasize how similar this code is. So up here, I want to explain hours. So hours now isn't going to be a fixed value. I want it to be a sequence going from 0 to however, hours, 0 to 50, wouldn't it? Length equals 1,000. But because we're explaining hours, age now needs to be set at some low value, which is obviously going to be 20. And then when I do it the next time, I'm going to have age, which is right here. Instead of 20, I'm going to do 50. Is that in the middle? 15, 20, 100? Yeah. And then we'll do a high value here, which is going to be 80. I didn't pause the video because I'm trying to show you how easy this can be to do. I need to grab the sequence and make sure every time I'm talking about hours, I'm using that sequence. Although, actually, I don't think I even need to rerun hours because hours isn't changing every time. It's really only age that's changing. So maybe we'll do that. Increase age to 50 and increase age to 50. I think that's it, isn't it? Let's give it a shot. Let's explain hours. Hours has a sequence, age is fixed. We start with the original plot. Oh, we want to plot it based on hours though, because hours is what we're trying to explain. There we go. There is not the right line. Oh, because we're not plotting it against age hat now, we're plotting it against hours. Haha! And that means I'm going to have to fix all these guys. This is why we pause videos. There's blue. You can probably already guess what's about to happen to the green. Ta-da! Now let's do a legend. Let me show you something that you might think is cool and you might not. I can do a paste. That way I only have to write hours equals once, and then I can just say 0, 25, and 50, except we didn't do 0, 25, and 50, did we? Man, I wish I'd memorized this. I think it was 20, 50, and then 80. And what the paste will do is it's going to stick hours with the numbers. I'm going to tell it not to separate things with a space. It did not like that I forgot the comma there. How about that? All right. You can imagine in class, they have to sit and watch me do this every time. We don't ever pause the video. But what is the effect of working more hours? Well, it decreases brain function. For young people, hours. Hours is not, this is age right here. Oh no, I'm going to have to redo the whole thing. Yeah, see, because it's still going to show the other one. All right, so Control-A, Control-R reruns the entire script again. That's really nice. What happens as you work more hours? Brain function drops. For young people, it only drops a little bit. For medium-aged people, as they work more hours, their brain function drops a lot. But for old people, working more hours is plummeting their brain function. So with a graph like this, you can explain a numerical interaction, which is pretty complex, fairly easily. Now, we did ask the question, how many lines should you have? I just did an example with 3 lines, but I kind of picked the value 3 a little bit arbitrarily. I wanted something low, something high, and something in the middle. Would it look better if you had more lines? Well, that's not hard to do. It took me, 10 minutes to copy and paste. So I started with 20, the red line before it, and then let's just do 30, 40, 50, 60, 70, 80. It looks a little cool. It's got the whole rainbow thing going. I would probably want to size my graph out, which would be hard in a video because it'll look like small graphics. But does this help explain it better? Well, I can still see that as hours increase, brain function goes down. It's subtle for young people and more dramatic for older people. It might depend on the client. It depends on your style. It depends on how you like things to go. I don't know that my wording would change. It's possible, of course, that you could have so many lines that your picture starts to look gaudy. So I would say you need at least 2 lines. 3 lines was nice. 4 lines looks cool. Having 7 lines, that's not bad. That's a style choice. If I want to do even more colors, I think I'm going to do a looping thing. Is there fancy programming you can do? Absolutely. And if you love computer programming, you'll probably enjoy looking through this code. If not, just ignore it. It doesn't matter. You could easily do 300 lines if you were that actively involved in doing that. Here I've done 12 lines. Let's see if I can make the legend work. It looks like I'm missing a close parenthesis. That, well, I got an error, but it also did the legend right. So is this better than 3 lines? Gee, I'd say you're starting to make it look pretty ugly. You've got so many lines going on here. If that's your style and you have a reason to say, I really want it to be like this, okay. I'll allow you to go for the style that you like, but I'd say we're starting to get a little too many lines for what's really needed here. And I paused the video to try to figure out what that error meant before, and I think it's because I'm starting to stress out R with how much is trying to go on here. But if you really like fancy coding, there's a lot of power in R. Here I've made brain hat into a function, so that all I had to do was call aligns on the brain hat. If you're into functional programming, you'll be like, oh, hey, that's cool. Otherwise, you know what, who cares? The point here is that we can use a plot like this to explain to a client what's happening. And what we're really trying to explain is a 3-dimensional picture like this. And I am not going to allow you to look at the code that does this because this is not code that you should be seeing, but just so that you can get an idea of the 3D picture here. This is what the data says the curvature is doing. So we have, as hours increase and as age increases, your brain function drops. Here on this corner here, your brain function is pretty high. As you age, that brain function will drop. As it turns out, if you age and you work no hours, that brain function will actually climb, but if you work a lot of hours, that brain function drops. So instead of trying to draw and explain this 3D rotating plot, which won't even work in RStudio, you have to do this in R because it's making a million plots right now and scrolling through them. But what you're doing is you're slicing this 3-dimensional picture into pieces, and then you explain each of those slices. And a plot like this, combined with the wording we used in the last video, will help a client understand numerical interactions. So in the next couple of videos, let's work through a couple more examples.